Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 8.2, Calculus using hyperbolic functions. First of all, we've talked about the simple trigonometric relation with the hyperbolics, and also we've talked about how hyperbolics differentiates. So the important thing to note right now is that there are also inverse hyperbolics, which are functions that can be differentiated, but ends up being a lot more complicated than necessary. At least that would be what we think. It's probably in the equation booklet, but learning the derivation is also important, so do take a note on this video. Okay, so let's get this started. It's gonna be quite long to derive one of them. So we have, first of all, arcsinh x equals to y, which we can rearrange such that sine y equals to x. And so we can do an implicit differentiation, which ends up being d by dx, and we have 1 on the left, then d by dx of sine y. By chain rule, we have dy by dx multiplied by cos of y, and so dy by dx is equal to 1 on cos y. So we have this expression. We can now substitute this with a square root of cos squared y, and converting this into using the identity that we have derived we didn't derive, I talked about last video. We have cos squared take sine squared equals to 1, so we have 1 plus sine squared over here. Now we can substitute the y, we can substitute, let's see, actually this is y, my bad. So we can substitute this equation into the solution to get 1 on square root of 1 plus x squared as our trigonometric polynomial expression, of our inverse sine function in differential form. And with that said, we can now kind of reverse engineer this whole thing to such that we can find sine or find arcsine in terms of x, which is gonna take a lot of space. Yeah, I might cut this into two so that we can fit everything. So we want to express arcsine in terms of x. So let's try that. First of all, turn arcsine into turn sine into exponential form. So let's see, x is equal to sine of y, and so we know the expression for sine y is e to the y take e to the minus y all over 2, that would be x. And by rearranging this whole thing, we have 2x is e to the y take e to the minus y. So the clever thing here is to multiply everything by e to the y, such that after rearranging to 0 on the left, we have e to the 2y take 2x e to the y take 1 as a quadratic formula. So this quadratic can be run through the quadratic formula, which will give us, let's see, minus b, which is 2x plus or minus square root of b squared, 4x squared, minus 4 times minus 1, so plus 4 AC, well, a is 1, so that's 1, all divided by 2a. So I've got 2 here. That would equal to e to the y. So over on the left, we can do some simplification. This 4 can be factorized out into 2's. So 2 can be factorized in front, such that x plus or minus square root of x squared plus 1, that divided by 2, and the 2 can cancel away, which means that e to the y is equal to x plus or minus square root of x squared plus 1. So, however, this whole thing is, well, I'm gonna show you how this plus or minus can be ignored, because after you take the natural log, you have natural log of x plus or minus square root of x squared plus 1. With that, we know we can hypothesize such that if I add two y's together, and given that it can be plus or minus, I can say that natural log of x plus root x squared plus 1 multiplied by x minus square root of x squared plus 1, they're all within the natural log, by the way. Due to the log rule, we can say that 2y equals to natural log of x plus root add natural log of x take root, which gives this whole expression, and that means that we can state that 2y is actually equal to natural log of just simply x squared take x squared plus 1, which is natural log of 1, which is 0. So what does this imply? Well, actually, this 2y should be written as y plus and y minus. So if they add together, so since two values add to 0, which means that one is the negative of the other. So this whole expression can also be written as plus or minus a natural log of x plus root x squared plus 1. So this solution, this plus or minus outside the bracket, would be the given solution for the equation booklet, and they are also allowed to ask you, why does this plus or minus comes out of the bracket in front of the natural log? In comparison to cosh, this doesn't happen, and so the plus or minus stays within the bracket of the natural log. So this is also one thing that we need to know, and you are supposed to be able to derive this plus or minus expression equals to 0 solution. So make sure you know how to do this proof. But in the end, this is the important bit that you need to take away, which is y equals to plus or minus natural log of x plus root x squared plus 1. That would be arcsinh. Now I'm gonna leave arccosh and arctange for you to experiment with in the question section, so bear with. For tips, we have, well, I think for hyperbolics, just for this particular sine and cos, learning the derivation for the algebraic expression is a lot easier than remembering the solution, given that you have some natural log of some value plus a square root. Is just too much combination of stuff. I would rather remember the derivation and not care about how to arrange every element of it and just do it on the spot. That's my own personal preference anyway. If you have other methods of remembering how to write them properly, then I don't think there would be a problem. But one thing that I didn't do for sine is that I didn't state the valid domain. And the valid domain for this sine turns out to be any real x, which is fine. That's a valid solution. However, for cos, for arccosh and arctange, it's not as straightforward as you think. So you have to look at the equation, find out what is invalid and what cannot happen, given that you need a real solution, of course. And then you need to state what their x has to be. So essentially that's all. I'm gonna let you do some questions now. So questions, I have these 4. Derive the following expressions. Make sure you state their domain. And yeah, basically just put them in terms of x. So I'm gonna, as usual, give you 5 seconds to pause and do whatever you need. And I'll show you the answer in 5, 4, 3, 2, 1. And the solutions are shown as follows. For the arccosh, the plus or minus, I think it's good to have. I didn't write that for arcsinh, which is a problem that I want to address at this stage. But other than that, everything should be fine. The reason as to why the domain has to be in the form of mod x is because if for the x squared terms, it doesn't matter if the value of x is a negative, as long as the magnitude of the x is larger than 1, then the squared would be larger than the minus, larger than the 1 that we are subtracting, which means that we have a square root of a positive number. Same for the arccosh function. For the arctange, it's important that this inequality is not small it's not a smaller than or equal to symbol, because if it's equal to 1, then we have a natural log of, well, 1. Actually, it might work. Let's see, it does work if we have equal, so actually that's fine, that would equal to 0. For this one, however, I'm kind of skeptical of this one. No, this one cannot be equal to 1, so this would just be smaller than, because if it's equal to 1, we have to divide by 0. That cannot happen. So yeah, essentially that's the domains. So take care when doing the larger than or the inequality symbols. They can trick you up, especially if you forget to write them down, then they will lose you some valuable marks that might swing you from an A star to an A. So do take care on that note. However, this will be the end of this video. I hope you've learned something. If you did, make sure to let me know in the comment section below. And if you have any questions, also do tell me in the comments. But for now, thank you very much for watching, and I will see you on my next one.